everyone. I'm Everton de Oliveira, the Professor Agua from the Groundwater Project. And I'm really happy to bring you a very good book. And as I was telling the authors here at the beginning, I believe this is going to be a classic very soon. It's a book that I really needed when I was younger. And now you have it all ready for you to understand and to use in your hydrogeology career. It's going to be very helpful, I'm very sure. So I would like to congratulate them for a job well done. The book is an introduction to hydraulic testing in hydrogeology basic pumping, slug and packer methods. It's William Woessner. He's a Montana University System Emeritus Regent Professor of Hydrogeology. He taught introductory and graduate courses in hydrogeological sciences, including well design and hydraulic testing for over 30 years at the University of Montana, Missoula, USA. The other author is Campbell. He is a principal hydrogeologist with NewFields in Missoula, Montana. Cam has over 30 years of consulting experience in hydrogeology, aquifer characterization, aquifer testing, water rights, public water supply development, remediation investigation, landfill permitting, mine permitting and remediation, corrective measure implementation, comprehensive environmental response, compensation and liability act, CERCLA, NEPA analysis, remediation, investigation, and municipal water supply, exploration, installation, and permitting. Wow, Ken, so good. And we have Eileen. Eileen is the big Eileen for the Groundwater Project. She's responsible for all the nice work that you've seen lately. And on top of that, she's also the author of this great book. She's an emeritus professor of the geological engineering at Colorado School of Mines, where she taught groundwater courses and advised more than 40 graduate students who worked with her on groundwater system investigations and modeling research projects. She's also past director of the Integrated Groundwater Modeling Center and retired president of Poeder Engineering. Thank you very much, the three of you. Thank you again for the nice work. Welcome. First of all, how did you team up for this work? And how was the behind the screen stories to get it done, please?
Well, we better not talk about any of the behind the screen stories, but it was a long, it was a long process.
Please, this is interesting.
Well, but starting after Eileen and I finished our hydrogeologic properties of earth materials book, we knew that we didn't have time and space at that point to talk about hydraulic testing. We talked about lab methods to determine hydraulic properties of earth materials, and we mentioned field methods, but we really didn't go into that. And we know we needed another piece of work that would address the hydraulic testing specifically. So in 2000, we started the process of trying to figure out how to make that happen. And about 2001, I submitted an outline to the Groundwater Project of what I thought would be an introductory level hydraulic testing book. And that went through, yeah, go ahead.
2021, right?
What was that?
2021, you mentioned 2001.
Yes, I know. I mean, it's been quite a process. So I submitted this outline and okay, that I thought was the basic material that needed to be into a beginning hydraulics analysis type of book. And, you know, that was passed around. And then I started writing a bunch of that material. And by 2002, I said, I'm in trouble. I got to get some help from the outside on other people who have expertise. So I got Cam involved because his career has basically been related to doing this work, you know, and a lot of other things too, of course, but he had lots of application. He works for a consulting firm, so a lot of practical application type of things. And then we worked on it some more, and Eileen got involved, and we said, well, man, we need more help. So we said, we better get Eileen involved because she'll add that expertise of going over the mathematics and carefully looking at things. And so she was a great addition to this three-person team. And then I think you have to recognize that these books are all fully reviewed. So we had numbers of reviewers who came in and went through and gave us suggestions and fixed our mathematical mistake if they found one. And we really appreciated all of the work that the reviewers did, and then the final production of the book. So it's been a long process, let's put it that way. But this is a great team to work with, and I think we worked well together, and we brought different expertise to the plate.
Yeah, I agree. Thank you. So in my humble opinion, hydraulic tests are arguably the most important tool for hydrogeology. And many hydrogeologists, they do not pay attention to that. Maybe it's too difficult, the mathematics, I don't know. So how is your book organized for those hydrogeologists that are unaware of the importance of that, which I believe it was organized in that way? Please.
Eileen, do you want to talk about that?
Yeah. We start by just talking about the purpose of testing so that people understand why they even want to do it. And then we give lots of illustrations that present the conceptual setting where the tests are done and help people understand that they need to understand the hydrogeologic setting before they design their test. From there, we kind of move on to how the tests are conducted and how the field data is corrected and analyzed before we dive into the mathematics. And that's what underpins the interpretation. So to help make that more accessible to people, we explain the math step by step with lots of diagrams, and we include lots of worked examples and links to exercises throughout the book so that readers can try to work out the concepts as they're reading, and we provide solutions so they can try it first and then go to the solution and see what we did differently than they did and perhaps learn from those differences.
And I think as Eileen has sort of laid out, I mean, we purposefully started the more complicated or the more mathematical sections in the same order every time we address them. We started with the conceptual model, and then we said, well, there's a mathematical expression of the things that are going on when you do a test like this, and then there's a solution to that. And these are the well-functioned tables and other equations and programs you can use to generate those. And then we went into how do you use that data to actually do an analysis, or if you have the data about aquifer properties, how do you plug them into those equations to forecast what the impact would be from pumping at a given rate, at a given time, at a given location. So, yeah, Cam, anything else?
I think you guys covered it pretty well. I would say, though, going back to what you talked about is, as you said, we started with a conceptual model. And you mentioned earlier that people sometimes get scared off by the mathematics, but in practical application, it's the conceptual part that is the most important to understand, because we see all the time people trying to plug inappropriate data in and mathematically analyze them and coming up with answers that are not meaningful. And so it's that conceptualization, both on the front end and the back end, that's the most important thing for people to understand. And these days, for a lot of people who are applying this information, there are online tools to help them through with the mathematics, so that I'm not sure that a super deep understanding of the mathematics is necessary to successfully apply these tools. It just is, especially in an academic setting, it's important for people to understand how this is all developed and how it's all applied.
Thank you. Yeah, I agree with you. But then why the preparation before the running test is so important? In detail. Well, so you went through quickly.
Sure. So the most important thing in preparing for that is to ask the question you're trying to. So we're talking about aquifer characterization in general, but we often have different reasons to characterize aquifers. So the most important thing first is, what questions are we trying to answer with this test? And then we need to collect the information that we have available to us in advance to understand as much as we can about the system that's being tested, so that we can design the test to fit the setting as well as the question that we're trying to ask. And because this is a textbook and we need to organize it into chapters and different categories. In reality and practical application, there's going to be overlap between some of the stuff, and a lot of it has to do with what it is you're trying to characterize. So the preparation is so important, because if you don't take into account everything we know about the system in advance and organize how you're going to set the test up, a lot of these tests are going to give back information that's of little value or worse, potentially misleading. And so by getting things set up, understanding the conceptual model to the degree we can in advance, and then designing the test with every step laid out in advance, it avoids mistakes. I mean, many times tests have to be started because planning was not complete in advance, or when we get done, the results that we have are difficult to interpret or provide little value.
I'm witness to that. I've seen this many times.
We all have.
Yes, that's true. So what about the execution of the test? You have an item in the book called Notes for Successful Execution, right? Could you explain this here, and please, how this connects to the whole chapter? Because this is at the end.
I think that Cam has hit that point already in a way. I mean, what we've seen from our years of experience in doing this kind of thing, looking at setting up tests and running them, is that what I found is that in the first half hour of the test, if things are messed up, if you don't have the right pumping rate, or the pumping rate is varying, or you're not getting measurements on the wells that you hoped that you would get measurements on, or some other failure of equipment occurs, in my view, it's best to just stop everything, because these tests are also very expensive. I mean, they cost a bunch of money because you have people involved and equipment involved. So my recommendation is always stop, take a look at the data in real time as it's being collected. If it seems like that it's not going to be something easy to analyze, a lot of these analytical solutions assume constant pumping rates, and they assume nothing else going on around that would interfere with the data you're collecting. So look at the stuff real time, the data, and then if things aren't going well, then you just, best bet is to stop, let it recover, and then start again with it working properly. Otherwise, you're going to run a 5-day test and spend thousands and thousands of dollars, and you won't have what you need to characterize the aquifer when you're finished. But I'm sure each of us have an opinion on this. So Eileen or Cam, why don't you chime in?
I agree. It's a short section, and that's what it says. Be cautious, be watching your test as it begins, and don't hesitate to stop and begin again if you find that there are problems.
That's very true. That's very true.
And a lot of those problems can be avoided with good planning in advance.
Yes.
Yes, yes.
You learn that with experience.
Yeah, well, you learn making mistakes, right?
Yeah.
And restarting the test. That's true. Yes.
And doesn't that apply to just about everything we do in life?
Exactly.
Yes.
That's true. That's true. So about the book, I understand that your book evolved somehow historically, which is interesting, right? From like Thais, T, and Jacob, then to one well testing, Packard tests. So why have you decided to organize it in that way? Is it, better to understand? What's the reason?
I think it's not, we weren't thinking, oh, let's follow historical development so much as that historical development started by analyzing some of the simplest conditions like steady state flow, and then moved on to transient flow. But they were thinking about just one aquifer, maybe confined, maybe unconfined. And then they moved on from there to look at multiple aquifers and how they might be interacting. And so we progress in that same sort of logical from simpler to more complex, the way history progressed. it also sort of progresses from designs that are easier to interpret. When you have one pumping well and multiple observation wells, it's easier to get your good data out of that, and then moves on to tests that are more challenging to interpret, slug tests and single hole tests done with packers and so on. That progression also orients towards the pumping test with multiple observation wells is better at getting large volume of material tested versus the slug tests, and the packer tests are more oriented toward more specific zones. So we kind of go from simpler and easier to evaluate and more commonly used to the more complex, more difficult to evaluate and less commonly used tests.
Yep. I think the other thing is not only historical, and maybe that's because that's how everybody else has done it. I mean, we have a great book on our groundwater project site that's a historic book by Cushman and DeRitter, and they basically, you know, as another good book on aquifer testing that's out there and that's available. But I think also that we try to include other tools like, well, what if you don't have a pumping well, or what if you just have data from performance tests of well drillers drilling a well and pumping it for an hour or two and recording what's happening? And because sometimes, you know, that's all that's available and you don't have the budget to run a fancier or more involved test. So I think we included that part specifically because often, you know, you have a lot of data out there that you could interpret if you knew how to interpret it. So we're trying to give you some tools to open up that area where you can get some estimates of hydraulic properties, even when you don't have perfect data. So we spend quite a bit of time talking about that. And I think that's a valuable contribution.
Yeah, I thought it was very valid because that's typical. We go to a place and we have a well there, you have some data, you know, and you can start from there. I thought that was a very, very good idea to have it on a book, because that's quite typical to run into that situation, right? So the math behind the test, as we mentioned, could be a bit scary for geologists in general, right? But I believe that the exercise, you know, and the text especially is very friendly in that way. For me, at least, it was. How have you thought out to reach, you know, the reach of your book? What is the audience, and how to get around this fear of math that scares hydrogeologists?
Well, I don't think it should scare hydrogeologists. I think that I always told my students, well, you know, when you read a scientific article and then there's a page of mathematics, and if you skip that, it's like you just skipped part of the text. You didn't read the rest of the article. You missed out on what was going on. But I think that Cam hit it in a sense too, is that we try to present it in a way in which we don't say you now derive the governing equation for a leaky confined aquifer analysis. I mean, that's not the purpose of the book. The book is trying to say that people have done this, and here's what they came up with, and then they estimated these difficult integrals, and they came up with a way to solve that so that they could use that representation. And I think that's what we're trying to get across to the students, that yes, it is mathematical, but people have looked at this and they've figured out ways to estimate these well functions, and so you can use that, you know, with understanding that what the limitations were of a particular method, and that it is an analytical solution which is pretty limited. And maybe hopefully we're trying to get across that might explain why when things don't quite work out, don't fit well, that there's a reason for it. And usually it's you violated some assumptions on these analytical solutions. And so how do you adjust? What do you do to try to make an estimate, even though you know that it's not the perfect situation? So that's sort of my sort of view of what we tried to do, at least what I tried to do. Math is I'm not as heavy duty as I would certainly like to be. Eileen, Cam, you know,
think
what
you
about your comments?
I think you nailed it.
Well, I agree. What about you, Kim? What do you think? Because you're a field, you know, experience.
Yeah, well, you know, I come from a very applied side of things, very practical, and I will say that a lot of times the people who are performing the tests have no understanding of the mathematics whatsoever, and as long as they understand what the purpose of the test is, what the data is necessary to collect it, they can be very successful. I mean, we've had crews that do nothing but go out and perform Oxford tests, and you know that there's more to it than just the math. And so I think it's not always necessary to understand the math completely to have successful tests. And likewise, you know, for you know practitioners who are out there, you know, they don't need to be able to derive these equations, you know, but it's helpful to understand at the level of your knowledge what went into deriving them, you know, and what are the inputs, and because having that knowledge makes it either easier to understand why certain things are necessary in the testing.
Agree.
And Eileen comes from an engineering perspective, so she could shed some light on what she thinks. Maybe she disagrees totally with that.
I don't know. I think you guys nailed it. Yeah, I don't think I have anything to add.
Good. So I have a question for you, because somehow you mentioned some software for people there. But for people like I was in a conference in South Africa, and many people from the poor countries in Africa were there. And they have quite a difficult time reaching softwares and material that are expensive to buy. So what are the basic tools, office tools, that you believe they should focus on acquiring, for example? Are there free? I think Cam mentioned something already, and I know that there is, but are free software that could offer a good start for them? How far could they go interpreting by hand, for example, the simple interpretations of the tests?
They can do a lot by hand, that's for sure. And that's how hydrogeologists did it for a long time before we had computers at our fingertips.
That's
so
true.
So all the work can really be done with paper and pencil, and the book, which again is free and easily downloaded. We do compare some hand-done results with software results, so we show that they produce comparable numbers. And we also provided a lot of links to various commercial software and to various free software. So if people have access to download, they can try those out.
Well, and I'll add that, you know, with people who do have a little bit of mathematical experience and software experience, there are a lot of things you can do just in Excel, or you know, people now who are younger than the three of us have developed a lot more tools in things like R. But I'll just give an example of, we had a hydrogeologist that came to work for us who just took Tice equation and created a simple Tice calculator. And I use that more than any tool that's out there. So you can plug in your radial distances, your pumping rates, and that kind of stuff, and very quickly spit out, you know, what the drawdown should be at different places. And it's a powerful tool. And it took him maybe an hour to set the whole thing up. And so, you know, he just went through and took the Tice equation, broke it down, and entered the inputs that were needed in there. And so I think people with a little bit of mathematical understanding can develop their own tools.
I totally agree. I think it's. I've been through that. Sorry, I've been through that. I had to. You know, you create that in Excel and you can go on your own. That's very true. Very true. Bill, sorry.
I mean, there's a lot. The whole reason that the book is designed the way it is in my world is that when I was teaching, I would always have the students do a hand curve matching exercises, because that's what they're going to do. That's the methodology that actually is used to solve those equations. And so I even provided graph paper in the book, and with as far as what tools they should have, if they have any kind of program that they like, PowerPoint even, where you could bring in a plot and stretch it and get so that the axes are actually the same and manipulate it, or in Excel you can do the same thing. You can do a lot with that as far as making plots and then getting a type curve plot and overlaying them to the same scales electronically with not a lot of work today. Yep. But I think the curve matching technology, of course, in the software is a sophisticated way to do what you would do by hand. And they use the same tools that they use in parameter estimation software and other things to basically take a complex problem and match things up to a best fit, a look, first cut mathematically, and then it's still up to the hydrogeologist to look at that curve match that may be produced by some automated system and say, does that make any sense? You know, should that be where the match is, or should we move it around a little bit and see how it changes? And so I think, again, that the book shouldn't be rejected when somebody looks in it and sees a bunch of plotted data on graph paper. It's just the basic tool that's used and automated in all of the programming that's out there. At least that's how I view that aspect. So that's why it was all set up with a sort of basic, simple approach. So people who didn't have those sophisticated tools could still do data analysis.
That's very good. That's very good. All right, guys. Anything else you want to add, please? Or if you're fine, I would like you to leave a final word for your audience. And I'm pretty sure this book is going to be very helpful for hydrogeologists out there, because it's badly needed, something like, easy to follow and to use. Congratulations again for your nice work.
Well, it was a real team effort. So I hope that the readers all appreciate that it took a team to basically put it together and to have it available. And we hope it is used because I see it as providing the tools that you need to analyze and apply hydraulic testing appropriately. And remember, those tools are being used to basically characterize the hydrogeological setting. We need those values of transmissivity, storativity, hydraulic conductivity in everything that we do, whether it's a water budget or it's a solute transport model. So we hope that it will provide a basic foundation for applying methodology to be able to analyze the hydrogeologic properties of materials.
Good.
Well, and I would just like to add that to Bill's, that he's right. Those quantitative characteristics of aquifers are important, but these tests can also add a lot of conceptual knowledge to the system, because many systems don't behave in those ideal manners. And so when you go in thinking you know something about a system, and then you see a different response, and it may be somewhere in between one of these ideal ones, that can be very helpful in understanding a complex system.
It's true. Eileen.
I just hope that the hydrogeologists will at least pick up the book and have a look. I think it's very well suited to introductory groundwater courses, but I hope that experienced hydrologists might also glean a few new ideas from it. And of course, it's free of charge, which is very nice in this modern day when our textbooks are so expensive that the students are having a challenge buying the textbooks. So
I agree.
I just would make a point on that from Eileen. I think what maybe people don't realize is that this is all voluntary work. None of the authors are compensated for any of this work of all the groundwater project books. And so that's something that I hope people realize, that this time and effort we've put in has been time and effort that we think is needed and hopefully will be valued by hydrogeologists.
Well, I'm pretty sure it's going to happen. It takes some time for things to catch, as we've seen working on the groundwater project. But definitely, those books are very necessary, and I'm pretty sure many translations will come for that book. It's very basic, very important. And again, congratulations for a job well done. I'm very proud to work with you guys and to see that you're putting all your expertise and intellect into producing such a fine material for us. Thank you very much. And the groundwater will thank you all for a great job. Thanks.
Thanks for having us.
Thank you.
Thank you, guys.
Bye-bye.